Hey, this is Dr. B here, and let's take a look at some acid and base formulas. Here's 6 that get used very frequently. The one that it all starts with is this one right here. The hydrogen ion concentration in moles per liter multiplied by the hydroxide ion concentration will always be 10 to the minus 14th. That's the equilibrium constant for water. It simply also says that the more hydrogen ion concentration you have, the less hydroxide you would have. If this was 10 to the minus 12th molar, then this would be 10 to the minus 2 molar. They always multiply through. If you're doing it with a simple pH-based system, well, they just add up to 14, right? 12 and 2 would equal 14. And these formulas are also a natural consequence if you're starting with this assumption here. But let's assume you don't know anything about logs and you'd like to have a complete little reminder. Fine. What's 10 to the second power? You should know that's 10 times 10, or 100. We can say that 2 is the log of 100. Therefore, noting that it's exponents right there, that's what the log really is. It's a focus on the exponent. 10 to the minus 2, well, that's 1 over 10 to the second power by definition, or 1 over 100. That's 0.01. So we can say the same thing. Negative 2 is the log of 0.01. So logarithms are really the exponents in these situations. If the hydrogen ion concentration is 10 to the minus 2, we've learned to simply say that the pH is 2, meaning we ignore the negative sign, and that's the power of hydrogen ions. So we can now say that the pH is the negative log of the hydrogen ion concentration. Similarly, 10 to the minus pH is the hydrogen ion concentration. Notice we're deriving these formulas. We can say the exact same thing, replacing H plus with OH minus. 10 to the minus POH is the hydroxide concentration, and the POH is the negative log of the hydroxide ion concentration. That's where these all come from. Fine. Okay, I'll give you the H plus concentration. You tell me the pH. Notice that the pH is the negative log of that number. So we just say take the negative log of 10 to the minus 4, enter it into your calculator, or realize, hey, the pH is 4. Here you could do the negative log of 0.1, or you could realize that's 10 to the minus 1. The pH is 1. Here I think you're going to need a calculator because you got to, who knows what the negative log of 0.84 is. Plug it in, you should find that it's 0.075. Take the negative log of 4 and you might be surprised that you get a negative number, negative 0.6, and that's possible. The pH can go below 0 for very strong acids. All right, here it's a little bit shifted, but you can see we're given the pH. You tell me the hydrogen ion concentration. I guess that would be 10 to the minus 7th moles per liter. Or you can look for H plus equals. H plus equals 10 to the minus pH, so you would be 10 to the minus 7th. You could turn that into a number if you wanted to, but that's fine. 10 to the minus 3 for that pH of 3. If it's 3.4, you could write 10 to the minus 3.4, but usually people want you to find out what that's equal to, and there it is. 10 to the minus 12.62 for that basic solution. The hydrogen ion concentration is very, very low. 10 to the minus 12.62, or 2.4 times 10 to the minus 13th moles per liter. Since all these things are true, you really only need one piece of information to calculate the rest. And these are common problems on tests. If you're given that the pH is 3.78, we should be able to figure out all of these things. My advice is for each one, just go to that thing equals. All right, the pH is 3.7, H plus they want. Well, H plus is 10 to that number, 10 to the negative 3.78. So plug it in, and that's what you'll get. If you want POH, look for POH equals. It's the negative log of the hydroxide ion concentration. That doesn't help me very much. So if you have to, look around a little bit more. Oh yeah, they add up to 14, so I guess it's going to be 10.22. Hydroxide ion concentration equals 10 to the minus POH. Do we have the POH? We do now, so 10 to the minus 10.22 or 6.0 times 10 to the minus 11. Is it an acid or a base? Well, just look at the pH. It's less than 7. I guess it's an acid. Can you give me an example of something with that pH? Oh, any probably fruit or something like that, perhaps a vinegar solution. That would be orange juice, might come in at a pH of 3.78. This is acid and base formulas.